Here we go for Chapter 8. Today is April 9th. Let me get my pencil going. The month is flying by. That comma shouldn't be there, but oh well. Okay, so it's April 9th, 2020. We're going to finish up Chapter 8 and probably start Chapter 9. We're going to pick up with empirical formulas. So before this, last class, we did percent composition. We're going to build on percent composition by talking about empirical formulas and molecular formulas. So an empirical formula just shows the simplest whole ratio of ions in a formula unit. So if you have a compound like benzene, which is C6H6, its empirical formula is CH. That's the simplest whole number ratio that you can have of carbons and hydrogens that can represent benzene. Octane is C8H18. To reduce that down, the furthest you can go is C4H9. Can't go any further than that. You can't have any fractions. It's got to be a whole number ratio. We can actually calculate the empirical formula if we're given a little bit of information about the mass of the compound. So I'm going to walk you through a problem, and hopefully it'll make the empirical formula, the idea of the empirical formula, make a little more sense. We have a sample of radium metal that was heated to produce radium oxide. And the question is, what is the empirical formula? Doesn't seem like we have a lot of information to go on, but we actually do. For these kinds of questions, where you're given a mass, we'll call this mass. Oh, come on. My pen is messing up all types of ways. Mass to empirical formula. Have to write a little slow here so that it catches up. Ooh, this is taking forever. Oh, it's going to be that type of day. I could have written this 10 times by now. That's supposed to say mass to empirical formula. Looks like trash, but believe me, that's what it's supposed to say. So the first thing you have to do is figure out the mass of each element. My internet is not liking me today. I think everybody and their mama is on the internet right now. Whew. Okay, so we have a sample of radium metal and we have a sample of radium oxide. Radium oxide means that we have some kind of radium with some kind of subscript and an oxygen with some kind of subscript. We don't know what the empirical or the molecular formula is, but we know that it's got radium and it's got oxygen. So you're going to need to remember your naming from chapter 6 for the rest of the semester, because you're going to see names of compounds. We need to figure out the mass of the oxygen. And to do that, we're going to take the mass of the radium oxide, if it'll let me write, 1.755, and we're going to subtract the sample of radium metal. Radium metal is just radium. So the difference between the two will tell us how much oxygen was added. Ooh, this is bad. So if you can, use your calculator and tell me, find the difference between 1.755 grams and 1.640 grams. Yep, 0.155. 115. So this is going to be our grams of oxygen. We already know our grams of radium because that was given in the problem. The second step is to figure out the number of moles of each element. Any day now, this is going to finish writing. I may have to redo this video just because the quality of the pen is so bad. So we have our moles, or our moles. We have our mass of oxygen, that's 0.115 grams. How do we go from mass to mole? We were just doing this on Tuesday. How do you go from the mass of something to the number of moles of something? Not Avogadro's number. That's if we wanted to know the number of things. If we want to know the number of moles from mass, it's the molar mass. That's right. The molar mass of oxygen is 16. You get that from the periodic table. That's going to go in the bottom. And we're going to put 1 mole of oxygen in the top. So you do that division, 0.115 divided by 16, and you get 0.007188. I'm not going to worry about sig figs here. From the periodic table, we're looking at the element oxygen. So that's our moles of oxygen. Now we need to find the moles of radium metal. We were told from the problem that we have 1.640 grams of radium. So why don't you try to take that number of grams and convert it to number of moles of radium. You'll need your periodic table. Did anybody get a number? You're going to take the 1.640 grams and divide by 226.025, which is the molar mass of radium. From the periodic table. So we're just doing the molar mass. And since it's an element, you just go straight to the periodic table, and that's where you find it. So 226 is the molar mass. We need to know how many moles. I may need to reset my internet, y'all. I don't want to disrupt class, but we cannot carry on like this because it's taking an eon just for me to write. So if you do the division, you get 0.007256 moles. No. I think that you may have done it backwards. Nope. I have no idea. You multiply. Okay. So let me try resetting my internet. So I'm going to unjoin and rejoin, and hopefully that won't kill everything. But I apologize for this. Internet is just not trying to let me be great. So hold on. So there will be problems. There will be problems where you have more than just two elements. And so you're going to take the smallest one, and you're going to take all the other moles and divide by that. But yeah, it's the same protocol for every time that you're trying to find the empirical formula. You won't always be given a mass though. We're going to go over that in just a second. But this is the steps for number 2 and number 3 are always going to be the same. I hope I answered your question. Okay. Other questions? Okay. So another way that you can figure out empirical formulas is from the mass composition. So we did the percent composition where you have to figure out the molar mass, and then you figure out how much carbon or how much oxygen, whatever the elements are in that compound, what percentage of the mass comes from carbon or from nitrogen. We can take that information and figure out an empirical formula. I'm like so tempted to test that pencil tool, but I'm not gonna. So the first step here is we're given mass composition. We can't do anything with percentages. We need grams. So we're going to assume that we have 100 grams of sample. You're going to do that every time that you're given mass composition and you're trying to find an empirical formula. You can't do it any other way. If we have 100 grams of sample, then our percentages become grams. So 92.2% carbon becomes 92.2 grams of carbon. Likewise, 7.83% of hydrogen becomes 7.83 grams of hydrogen. Now we can work with grams. The second thing that we have to do is just like before, find the number of moles of each element using the molar mass. So if we're going to figure out, go ahead. Yes, exactly. So we'll start with the hydrogen, so that's what you said first. So I hope everybody heard that. So to find the moles, of hydrogen, we're going to take the number of grams that we have, which is 7.3 grams of hydrogen, and we're going to take our molar mass, so that's 1 mole, and we're going to put it over the number of grams that there are in 1 mole of hydrogen. And that is from the periodic table. So go ahead and figure out how many moles of hydrogen we have, and then try to figure out how many moles of carbon we have. Yeah, what's your question? For the empirical formulas and the molar mass and stuff like that, I'm pretty lenient about that. So as long as you're in the right ballpark, don't give me 12 decimal places, but if you give me one or two, that should be fine. So did anybody get how many moles of hydrogen we have? So hydrogen should be 7.75, and then for the moles of carbon, we're doing the 92.2 grams of carbon, 1 mole of you should get 7.68. So that's pretty close. We still have to do that third step, which is find the simplest whole number ratio. You're not smart. Okay. Yes. So when you take those two and divide them, you should get something in the ballpark of 1. That's not always going to be the case. But once again, we get 1.01. So we take the 7.75 moles of hydrogen, divide that by the 7.68 moles of carbon, we get 1.01. So what does that mean in terms of the empirical formula? We know that the ratio of hydrogen to carbon is 1. So what is our empirical formula? Pretty much. So I always put the carbon first. When you put hydrogen first, it implies an acid. But you're right. So there's 1 carbon and 1 hydrogen. That is the empirical formula. We don't know how many carbons and how many hydrogens there are in acetylene, but we know that the simplest ratio between carbon and hydrogen is 1 to 1. So once you get that ratio, let me get my pointer. Once you get this number here, then you have to apply it to the elements that we're just working with. And this is saying that we have 1 mole of hydrogen for every 1 mole of carbon. When you write that as a chemical formula, it's simply CH. Questions about how we went from dividing the number of moles to getting the empirical formula? Yes. So the empirical formula is CH. A lot of work just to write an answer for 2 letters, but yeah. All right. So we're going to build on this. If you don't understand empirical formulas, then you're not going to understand the next step, which is molecular formulas. So that's why I want to let it simmer a little bit. But if we're good, we're going to keep it pushing. So we got our empirical formula CH. But the molecular formula tells you exactly how many carbons and how many hydrogens you have in a compound. You can get this information as long as you have the molar mass of the compound you're interested in. Acetylene has a molar mass of 26 grams per mole. Now I'm just curious. I'm going to see if I can write something. Just for, this still looks kind of bad. So I'm still stick with typing. From last time we said that our empirical formula was CH for acetylene. We're trying to figure out the molecular formula, which is going to tell us exactly how many carbons and how many hydrogens. To figure out what the molecular formula is, you first have to figure out what your molar mass of the empirical formula is. So that's step 1. Find the molar mass of the empirical formula. So go ahead and do that. The molar mass of CH shouldn't take you that long. Probably don't even have to reach for a calculator. Does anybody have a molar mass for CH? Yep. About 13. Now that we have our molar mass of the empirical formula, the second step is to divide the molar mass of the molecular formula by the molar mass of the empirical formula. So you have to make sure to keep those 2 things straight. The molecular formula We don't know it yet, but we know that the molar mass is 26 grams per mole. We know that we have to divide that by the molar mass of our empirical formula, which we just found. You divide those two, and you get about 2, okay? So that tells you that you have 2 times the molecular or the molar mass of your empirical formula. So you have 2 times your empirical formula. Well, you multiply everything by 2. That comes to C2H2, which not even sure that I can do subscripts here. Nope. So you'll just have to believe me. Try to write it. No, my pen is still acting up. So we're just going to leave it at that. Those 2 should be subscripts. But your molecular formula is C2H2. Does everybody understand how we got that? Because we can talk it through again. Okay. So let's try a problem, a whole problem. Lindane is an insecticide that causes dizziness in humans. Find the molecular formula for Lindane given that its percent composition is 24.8% carbon, 2.1% hydrogen, and 73.1% chlorine. The approximate molar mass is 290 grams per mole. So what I'll do is I'll talk through the steps of how you solve this, and then I want you to try to solve it. We'll have 2 breakpoints. I want you to first figure out the empirical formula and then figure out the molecular formula. So the first thing you're going to do is find the empirical formula just like we did before. Assume you have 100 grams of this substance so that you can take those percentages and make them grams. And then you go from grams to moles. So try to get to the empirical formula. I'll give you like 5 minutes, and then you can put your answer in the chat box. I'll just be sitting here waiting. Yeah. So you take, I mean, if they all look about the same, you don't have to bother with the division. But you take the smallest one and then you divide for all the others. So if you had 1, 2, and 3, let's say, you would take 3 and divide by 1. You take 2 and divide by 1. And you already know 1 divided by 1. Does that make sense? Okay, good. So let's say that we had 1 mole of carbon, 2 moles of hydrogen, and 3 moles of chlorine. That's not the answer, but let's say that's what it was. To figure out your empirical formula, your lowest number of moles is 1 mole of carbon. So you would take the 3 moles of chlorine and divide by 1, and that would give you the number of chlorines you have in the empirical formula. Then you take the 2 for the hydrogen and divide by 1, and that tells you how many hydrogens you have. And then for the carbon, you have 1. You're welcome. When you get your empirical formula, put it in the chat box. I'm going to start typing here what I got for my moles of carbon. Yeah, that's what I got, y'all. That is the empirical formula. So those are the number of moles that I got. And then for the empirical formula, so it's just, there's some rules in terms of when you write a hydrogen first. And generally speaking, if something has carbon, you write the carbon first, then the hydrogen, then the nitrogen, then the oxygen, then the phosphorus. You don't have to worry about that. I'm not going to mark it wrong because you didn't put it in the same order as me. As long as you have the right elements with the right subscripts, you're good. So how many of you were able to get the empirical formula? You can raise your hand or say yes. Did nobody else get to the empirical formula? Okay. So Wesley, you got it. Cool. Okay, so converting grams to moles, you have to use molar mass. So that we started doing like the first chapter or the first section of chapter 8. So you might want to review that part, because if that stuff doesn't make sense, then this is going to be difficult for you. Yeah, so not Tuesday, but Thursday of last week, so a week ago. Okay. The next part of the question is figuring out the molar mass, because we're not done. Or not the molar mass, the molecular formula. So we need to figure out what our molecular formula is, and we have to divide the molar mass of the molecular formula by the molar mass of the empirical formula. You have to figure out the molar mass of the empirical formula first. And I'll go through that since we had a question about how to go from grams to moles. This is it'll sort of help you. This will at least help you understand what a molar mass is and how to find it, because you need that to convert from grams to moles. So for our molar mass of the empirical formula, you're going to take the 12.01 grams from your carbon, and that's from the periodic table. So you look at the periodic table, you find the atomic mass of the element you care about, and you express it as grams. And you add all of those together. I'm pretty sure that's what I got too. Similar, yeah. So it depends on what periodic table you're using, or if you're just asking Google. So I got 48.473 grams per mole. If you get 48.562, you're going to get the same answer when you do the division. So the molar mass of the molecular formula is 290. And we're going to divide that by our empirical formula. What is that number? Yeah, 5.98. That's approximately 6, okay? So when you're that close to a whole number, use the whole number. You shouldn't get a fraction like 5.5. If you get a fraction at this point, then you know something's gone wrong. So now we know that the molar mass is 6 times the empirical mass, which means we have to multiply our empirical formula by 6. Wow, I finished typing that like seconds ago and it's still coming up. Get it together, Blackboard. Yep. So you just add subscripts for all of them. So it's not always going to be that easy. But yes, that it's the same exact process whenever you're doing this. So this is the most complicated that it will get for empirical formulas or molecular formulas. It's 12:06. Because of the technical issues we've had, I'm not going to start chapter 9 today. Empirical formulas and molecular formulas are usually a little bit difficult. So your homework for today will just be a problem like the one we just did. I did record this. I'm not sure how helpful it will be. I mean, the typing portion probably helpful. But how many of you want me to put just what we did on Blackboard or on YouTube, just for your reference? You can raise your hand if you want me to put it up there. Okay. That makes less work for me. So I will just put this up here as is. Instructors struggle too. This technology, I'm ready to fight. So we'll start chapter 9 on Tuesday of next week. So we will probably take about 3 class periods to cover chapter 9. And looking at the calendar, actually, let me stop this recording right here because this is family business right here. We don't need to put this on YouTube.